Good morning, everybody. I'm Marco Bazzani. Many thanks to VTM for inviting me to this speech and for having the possibility to describe our vision of mobility. As I said before, I'm Marco Bazzani, Innovation Manager, and now I would like to briefly introduce Teoresi with the words of a journalist on an important Italian magazine that define us as an international company that develops the intelligence of devices, adding the brain in order to make them smart. And in my opinion, this is a very nice definition of company that consider itself as a system integrator. Here are some figures about Teoresi. We are a group present in 4 countries, Italy, United States, Germany and Switzerland. Wait a second.
Attention please, is about to start the conference in the webcast area.
We are more than 1,100 colleagues, mainly involved in smart transportation. About 85% of our turnover is related to mobility in terms of ADAS system, in terms of autonomous driving system, connected vehicle, electric vehicle, and shared mobility. Now let's talk about mobility. Mobility is moving fast and is changing the world and changing how we are living in our world. In terms of speed, in terms of number of trucks available on our roads, in terms of services and new services, or better, in the way we consider the mobility in our present, in our future. It's a long story. We start in the 80s, in the 70s with a muscle car in the United States, then postponed in the 80s in Europe. Then at the end of the 90s and the beginning of our century, we started to add multimedia to our cars. For those who are from Turin, I don't know if they remember the startup Vitaminic from a student of Politecnico di Torino that was involved in shared music, in the possibility to sharing music, and also added in a car. In the second decade, in 2010, we add the connectivity to our car. And then, in the last years, we are living another evolution where a vehicle is involving in something that integrates more aspects around our car. We pass from connected car to assistive car. And also the regulation is changing. You will know about GSR regulation for Europe and the deadline of the next year, 2024. Also the European Union is asking us asking to the car to be active in taking care of the health of the drivers. In this way, we have a new perspective. We focus on the driver, so in a perspective of where the driver is in the center of the process instead of a vehicle. However, to reach this goal and the possibility to have a new revenue stream about this, we meet some issues. First of all, we need a way to deliver new features, features idea. We need a powerful hardware able to implement these new ideas. Right now, we are not able to wait any new vehicle to implement the new services. And also, as also repeated in the previous speech by Deutsche Telekom, the connectivity is a must. So we should consider our vehicles as always on. And in these terms, we have to consider the opportunity that the connectivity give to our work, to our vehicle. Now I would like to show some projects that we decline, in which we decline the statement of the connectivity is a must. Among an Italian project, Centro Nazionale Mobilità Sostenibile, and a European one. Centro Nazionale di Mobilità Sostenibile is one of the 5 national research centers founded by Next Generation EU program, and also from the ministries of our government. And it consists in a very, very big project that includes 25 university and research centers among Italy, and 24 large size enterprises, and touch all the aspects related to the sustainable mobility. From the vectors, we work on air mobility, on the road mobility, waterway, etc., railway, and the core technologies used in this type of mobility, from autonomous to connected to new propulsions, etc. We can say that in 3 years, we should be able to address a new roadmap for Italy in order to reach the target of 2035, with decarbonation. In particular, Teoresi is involved in 3 spokes. One is on air mobility, and 2 are related to vehicle and to the cars. In this project, they asked us to give information to the user in real time what are happening near the car, and to predict what will be the situation of the traffic on the streets in 1, 2, 3 seconds more in the future, and 1, 2, 3 minutes. And this is very complex, because we have to consider all the sensors equipped in a car to recognize and to map the environment, and also we have to consider the communication between vehicles and infrastructure in order to exchange information. But we are ready to reach this goal. Another project is a European project funded by European Union, and is very specific project related to 5G, or better, to how to demonstrate that 5G is important and essential for new services around mobility. In this particular case, we will use 5G in order to transmit all the information acquired by an autonomous driving system, such as our prototypes, in order to give this information to an edge computing and remapping the environment, and to be able to reconstruct again the dynamics of an accident that involve autonomous driving system with other vehicle or pedestrian on the street. In particular, in this project, as I said before, we will use our prototypes equipped with sensors, with radars, with LiDARs and cameras. We will use our drive-by-wire systems that we integrated in this car in order to... there is a video? in order to reconstruct in 3D the environment of around the car. Okay, so now I would like to take a look again to a point. If you remember, I already showed this slide, and I think it is very important to focus on another aspect. We say that we are involving in a transformation, in a driver-centric approach instead of a vehicle-centric approach. Another big aspect is consider the time to market of implementing a new solution. As I said before, we are not able to wait the presence of a market of a new vehicle for deploying new services. So we have to find something different to work on. And as you see in the titles, we consider software-defined vehicle as one of these main topics to solve these issues. And we can start by these figures. In the next future, about half of the cost, of the total cost of a vehicle will be related to the electronics component of a car. And right now we have a plethora of ECUs on board of our car, about 30, 40, 50 ECUs considering different models of car. And this electronics is useful. Also is the hardware that support a lot of software for taking care about the driver. If we consider the first chart, we can see that there is 10 times of line of code in a luxury car instead of a Boeing or a fighter, a military plane. So this huge amount of code of softwares are not able to be deployed every time in a new car. We have to change the mentality. We have to change the approach. And right now we have an hardware with perhaps with an high-performance hardware with several sensors, HD cameras, microphones, ultrasound systems, a very important and high-performance computers on board on our car in order to process all this huge amount of data. On the other hand, we have a software components that is able to define new functionalities, especially if we consider all the aftermarket aspects, or if we have to consider the updating of software over the air. So I don't have to put my USB on the socket to update my firmware, or I have to recall the car in an office in order to reload all the firmwares. And also, as we have in our pocket, we have this type of smartphone that are able to call, to send messages, but almost of our a lot of our applications are hardware independent. So we don't interest if WhatsApp is related to a Samsung or used in Apple or in Nokia or in Motorola systems. And this is the future, our ideas of deploying a new application on a car. So they should be vehicle independent. To reach this target, we need an open architecture where the car functionality are defined by software, SDV, through an hardware abstraction. I don't want to take a lesson about SDV and what is hardware abstraction. However, I would like to list some points that are important in our vision about SDV. First of all, it improve the customer experience of our drivers, because with SDV we can provide more personalized features. We can, of course, enhance innovation, because we can deploy new application and develop a new application without recall a car, but directly over the air, downloading from the cloud. We can improve the efficiency, because if we will use standard components for all the cars, all the vehicles, we can reduce the complexity of the cost of the component. And of course, we can, with SDV, we can improve the vehicles and the drivers' safety and security. How we implement and deploy this concept with a systems that is oops, sorry. Ooh, I don't have a video. No. Oops, I'm very sorry. I should be with a video. Oh, okay, thank you. So the idea is to try to abstract all the sensors available on a car and try to understand the health of the driver or the attention of the driver itself. If the hardware is able, of the car is able to abstract the sensors from the steering wheel, from the brake, from the throttles, we can use this sensor in order to detect the style guide of the driver. We can detect the health. However, if in the car are present new HD cameras, we can use also the camera internal the cockpit in order to detect also the health status of the driver and the drowsiness by finding the eyes and the movement of the eyes. And this is our concept, this is our prototype made in SDV, in the SDV architecture, in order to really create an environment where SDV is demonstrated. And considering this last slide, we can say that really Teoresi is an engineering company for human life that take care about the driver. Thanks for now for your attention, and I'm ready for any questions.